solve this question on Booth's algorithm, which was asked in 2023 examination for the university. And in order to solve this question, we have here the number which will be multiplied with this number. So let us write those numbers first. So we have to multiply 0 0 0 0 1 0 0 1 with 0 1 0 0 1 0 1 1. So what we have to do, as you can see in the table, we have to group the multiplier in parts of 2 like this. So first we will take the 2 bit, then we will take next 2 bit, then we will take next 2 bits, and then we will take last 2 bits like this. So we will take in 2 bits to multiply, and this number we will use for logically shifting to the left. As you can see in the table, we have LSL in this column. So let us start the procedure. This is in this tutorial I am not teaching you Booth's algorithm, but by solving this question you will understand how to solve the questions like this in your examination. So this is question centric tutorial where you will be understanding how to solve any question on Booth's algorithm. So this is your step 1. So in step 1 we have to assume few things like input carry is 0. This is the common step for all questions. First we will assume input carry is equal to 0. Okay. Running total or partial sum is 0. So it will be a 16-bit number which is having 0 0 0 0 0 0 0 0. Now after this is the 2 things that you will assume. Also the n is also assumed to be 0. So 3 things we have assumed. Now what we have to do, we have to take the first 2 bits of the multiplier. So if you check, it is 1 1, that is 1 1. So let us take 1 1. So let us name it B for some time. So it is 1 1. So in the table, if you see ALU table, you have 1 1, you have A plus B, A plus minus B. So that B is different from this B. So as of now, just be with me, ignore the notations. I am just taking these 2 bits for B, that is 1 1. Now do C in plus B. C in plus B, you will have 0 1 1. Now look in the table, you will find out that 0 1 1, where is 0 1 1? Here. So for 0 1 1, what are the details in the table that we will see? So for 0 1 1, what is the detail? For 0 1 1 in the table, for 0 1 1 in the table, LSL is what? LSL is what? It is 2n. Okay. Then what is the ALU operation? It is A plus B or A minus B. It is A minus B. And what is carry out? Carry out is 1. So this carry out you will take this carry out as a carry input for the next iteration. That I will note. Now see. So your n value is 0 here. So this 2n will be 2 into 0, which is 0 bits logical shift left. Now, so this B means your multiplicand. This is 0 0 0 0 1 0 0 1. So you will shift it by 0 bits because LSL you have got 0. By multiplying 2 with 0 you have got 0 bits. So now what is your A? A is all zeros that you have. So write all zeros. 0 0 0 0, then 0 0 0 0, then 0 0 0 0, and then 0 0 0 0. 16 bits you have to write because you want the result in 16-bit binary. Now what is B? If you shift your B by 0 bit, it will be the same number, which is 1001, and then 0 0 0 0, and all those zeros on the left doesn't make any difference in the magnitude. So if you do the subtraction in your calculator, 0 0 in the binary mode you can do it. So let us do it. So 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 minus 1 2 3 4 1 2 3 4 1 2 3 4 and 1 0 0 1. So like this. So you can copy first last 16 digits. So it will be 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1. Sorry, it is 0 triple 1 0 triple 1. Now this will be your A for next iteration. So this is A for next iteration. Okay, so let us take C out 1, that will be C in for next iteration, and A for next iteration. So this is your step number 2. Step number 2. In the step 2, increment n by 1. Increment n by 1. So n will be what? 1 now. Previously it was 0. So now what is your C in? C in was C out of the previous, which is 1. What is your B? B is your multiplier, which is 1 0 now. 1 0. We have taken 1 1. Now we will take 1 0. So what is C in plus B? It is 1 1 0. So now for 1 1 0, where you can look in the table, 1 1 0, that is LSL is what? 2n. LSL is 2n. That means 2 into 1. That means 2 bit left shift. Logical left shift. Okay, what is the C out again? C out is 1. That is the case. Now you can copy the previous A, okay, and do the left shift by 2 bit. So and then do the subtraction. So let us do here. Let us do A minus B, and this B is shifted multiplicand. Shifted multiplicand. So let us first write A. So A was, which was previous A, always you will take, but the B that you will take will be original one only. So always you will shift the original M. Original M you have to shift. So original M we will shift. So it will be, first I am writing A. So 1 1 1 1 1 1 1 1 1 1 1 1 0 1 1 1. And then what is shifted B? You have to shift this 2 bits. So you will add 2 zeros on the left and write the same number. That is LSL by 2 bits. So you will add 2 zeros, and then you have 0 1. Sorry, you have 0 1 and 1 0. 1 0 1 1 you will have. So that is your same number, and you can add zeros, no problem, because it won't change the magnitude. So if you subtract it, what you will get? So it is easy subtraction, but I recommend to use calculators always. So 1 1 1 1 1 1 1 1 1 0 triple 1 minus 1 2 3 4 1 2 3 4 1 2 3 4 0 1 0 0. So I used to speak 1 2 3 4 so that I don't have any confusion in how many ones and zeros I have typed, because it is same 1 1 1 1. So if you do this, you will get again 1 1 1 1 1 1 1 1 1 1 0 1 and 0 0 1 1. That is your answer, and it will be your new A. It will be your new partial sum. And again, whenever you have the multiplier shifting, you will take the original one only. So that is your step 2, and you have got C out is equal to 1. So that will be C in for the next step. So what will be step 3 now? How can we do step 3? So if you talk about step 3, so in the step 3, what is the procedure for step 3? For the step 3, you can increment n by 1. That means n will become 2 now. C in is the C out of the previous step, which is 1, so it is 1. B is your next 2 bit, which is 0 0 now. So we will take 0 0. So we will take 0 0, which is 0 0. So C in plus B is what? 1 0 0. For 1 0 0, what is in the table? 1 0 0, you can see here 1 0 0. So it is 2n a plus b and C out is 0. So C out is 0 here. C out is 0 here. So I will write here, that is better. So C out is 0. Okay, and we have to do a plus b, and we have to do logical shift by 2n. So n is what? 2. So it will be 4-bit shift. 4-bit shift. So let us write a first, then we will write shifted b. So new a is what? This is your new a, this one. So we will write new a here, which is 1 1 1 1 1 1 1 1 1 1 0 1 0 0 1 1. Now after this, what can you do? You can write the shifted b by 4 bits. So you can add 4 zeros here, 4 zeros, and now you can put your number which was here. So that will be shifted. So 1 0 0 1 is here, 1 0 0 1 and 0 0 0 0 0 0 0 0. So just addition we have to do to get new partial sum. So 1 2 3 4 1 2 3 4 1 2 3 4 1 2 3 4. Whenever say 1 2 3 4, I count these numbers 1 2 3 4 to type correctly in the calculator. So 0 0 0 0, then 1 2 3 4 1 2 3 4 1 2 3 4. So it doesn't create confusion. That's how I do type in the calculator, by speaking if I have taken all the correct. So if you do this addition in the calculator, last 16 bits you have to take, which is 0 0 0 0 0 0 0 0 0 1 1 0 and 0 0 1 1. Okay, so that is your new partial sum. Okay, this is your new a. Now this you have got. So now we can go to the new step. So I think here I have written C out is 0, fine. So that will be C in for the next step. So if you go to step 4, so you can get in the step 4 you can get n is equal to 3, which is incremented by 1. Previously you will have 2, here you have 3. What is C in? C in is what? C in is 0, because C out was 0 previously here. So that is your C in. Now what is sorry. So what is the next 2 bit that you will have? That will be your last bit. So it is 0 1. Okay, that is your 0 1 0 1 C. So your B is 0 1. So what is C in plus B? C in plus B is 0 0 1. So for 0 0 1 in the table, you can see here basically. If you cannot see, I will make good space and tell you 0 0 1 here. See, for 0 0 1 in this row, you can check that LSL is 2n, a plus b and C out is 0. So we will use that only. So LSL is 2n, a plus b and C out is 0. That means for 0 0 1, what is C out? C out is 0. LSL is what? It is 2n. LSL is 2n and LSL is 2n and what is the operation? A plus b. So A will be previous one, B will be your multiplicand shifted by 6 bits. 2 into 6, 6 bit. So what is A? We will write. So A is what? 0 0 0 0 0 0 0 0 0 1 1 0 and 0 0 1 1 0 0 1 1. Now 6 bit left shift means 6 zeros you will add, and then your number you will write, which was 1001. So it is 1001. So 1001 and then all zeros. So we can do addition and get new A, which will be, and here you have got C out 0. So if you add it, so if you add it, then you are going to get 0 0 0 0 0 0 1 0 1 0 1 0 and 0 0 1 1. So this is, see, now you have to stop because you don't have any numbers to multiply. You have used all 4 steps to multiply or 8 bits in 2 bit combination. Also you have to stop when C out is 0 and multiplier is 0 0. So for 0 0 0 you can check in the table, it is A plus 0 only. So even if you add plus 0 in this case, you will get the same answer. So that means you can stop here. So this is your answer. This is your answer, 0 0 1 0. So basically 1 0 1 0 1 0 0 0 1 1. If I talk about the number, if I ignore the other bits. Okay. So what can we do? We can also try to check this in the calculator, and then we can verify our answer in the calculator. Always do this in the exam. You have to verify your answers in the exam so that there is no mistake in the end. Otherwise there can be deductions in your marks. So see, I will show it to you how to do it. So first of all, I will make it minimize and on the camera. So if we do that, so basically see, I will have the calculator and I will also show you what is my result. So I have taken the last 16 bits, 4 4 4 4. So 0 0 0 0 0 0 1 0 1 0 1 0 0 0 1 1. So now we will put the number and multiply them. So I am in the binary mode and let us put the number. So number was 1001 1001 multiplied by what was the number? It was 0 1 0 0. It was 0 1 0 0 and then 1 0 1 1. So it is 1 0 1 1. So if you check, this answer is equal to, so you have got an answer. I will take a photo of this answer. Okay, I will take a photo of this answer. So I have taken the photo of this answer, and okay, so we will match our answer with the calculator's answer. So if you check closely, see, if you check it, what you will get from the Booth's algorithm. So you can check, I have got 1 0 1 0 1 0 0 1 1. So it is 1 0 1 0 1 0 0 0 1 1. Same again, if you check last 16 bits also, so 0 0 0 0 0 0 0 0 0 0 1 0 0 0 1 0 1 0 1 0 1 0 1 0 0 0 1 1 0 0 1 1. So these are your answers. Okay, so that's how you have to do your Booth's algorithm questions. If you have any doubt, you can comment. Okay, see you.